Hello everybody. Today we are going to be talking about Dynamic Host Configuration Protocol, or DHCP. Chances are that you have already been using it. Public Wi-Fi, some home PCs, and any place that has lots of devices or lots of devices coming and going uses DHCP. We use DHCP to make addressing easier to manage and to automatically give end devices on a network additional information, such as, for example, a default gateway. This works through the use of address pools and reservations, but we will get into that later. DHCP was based off of something called BootP and was refined in 1994. And the first implementation of DHCP v6 for IPv6 addresses was put forth in 2003. DHCP works by the DHCP server listening on port 67 and the DHCP client listening on port 68. There's an acronym that describes this process called DORA, D-O-R-A. So let's get into it. First, we have a DHCP client and a DHCP enabled router. So the first thing that happens is this DHCP client broadcasts a discover message, and then this DHCP router will be listening on port 67 for this discover message. Once the DHCP server receives a discover message on port 67, the DHCP server looks through its pool of addresses that it is allowed to sign and offers one of those addresses to this DHCP client. Once the DHCP client receives the offer, it broadcasts a request message just like it does with the very first discover message. But this time, it also produces a gratuitous ARP first to see if any other client on the network has the address that it was offered by this DHCP server or router. If the client that produces this gratuitous ARP, so right here we're talking about this one, doesn't receive a response, then there are no other clients. These would be other clients. There are no other clients that have the address that was offered by this DHCP router or server in this instance, in this network. Then the client that received the offer broadcasts a request message, which is the R in DORA, which tells the DHCP server that the address has been accepted. The A in DORA stands for acknowledgement. Once the DHCP router or DHCP server receives the request, this whole process reaches its final phase. The DHCP server sends an acknowledgement, a DHCP acknowledgement, with lease information and any other configuration that this DHCP client requests. Now we're going to get into the commands. So, right here, we are talking right now about this yellow network right here. So let's go through some of these commands and the steps that you need to do to get DHCP enabled so these clients down here can get addresses coordinating with this network. So the first step is to plan which addresses you want excluded from an address pool. you exclude addresses for devices that don't move or always need the same address, such as printers or scanners. So you see right here, we have a printer whose IP address is 192.168.0.20. So we need to go in here and we will first exclude this address. There we go. You can also exclude a range of addresses by putting your lowest address here, space, and putting your highest address here. For example, there we go. So right now, if we entered this command, it will exclude all addresses in between this range. So 20 all the way through 25. But since we only have one printer or one address that needs static IP, we aren't going to do that. Next, the next step is to configure a DHCP pool name. So let's go back to our commands here. And here is the first pool name that we will be using. It's better to use pool names that can't be interpreted the wrong way. So you just don't want to call it pool 1, pool 2, pool 3 unless you have documentation which says what each of those pools are for. So right here, since we want this DHCP enabled router to push out addresses to our 192.168.0.0/24 network, we are going to call our pool 192.168.0.0. So we will just copy this, bring up our command line again. There we go. Now we have a pool made. If you note it, if you look carefully, we have a config here for global config, but now it's DHCP config, which is definitely what we want. After that prompt has changed, you are ready to tell the DHCP server which range of addresses it can give out. So down here, we'll go back to our script. And the way we tell this DHCP server which addresses it gets to give out is through this network command. So we want to give out addresses to the 192.168.0.0 network with our /24 subnet mask, and we don't want it to ever give out this 192.168.0.20 address because that's our printer. But since we excluded this, it will not give that address out. So now we are going to put this network command in. Just paste that. And now every DHCP enabled device will get an address based on this range, excluding this IP address. And now we get to some of the other options you can do. So right here we know, since this is a small network, that in order to get out of this network, we need a default gateway. However, you can set DHCP to give that default gateway information out whenever a client requests an address. And that is done using the default router command. So this default router command is basically your default gateway, and this is the address of your default gateway. So we will just push this into here. Default router. Hit enter on that. And now, whenever these DHCP enabled clients request an address, it will automatically propagate this default router command as the default gateway. So another thing that we can do is show it where our DNS server is. Right now, I don't have a DNS server out here, but this 8888 is Google's DNS server, so we will just copy this and we will put it in here. Another thing that you can do is a domain name, and that is done by this command here. Because I don't have a domain set up, I'm just going to show you what it is, what it looks like. Domain name, and then you can do something like here we go, example.com or hawkeyecollege.edu. Anything is good there. So now let's get to something else that you configure that we talked about earlier. It's called a lease. What a lease does is it is the duration which a device gets to hold on to the address assigned to it. So the default is a 1-day lease, and the device will automatically renew that lease after 50% of the lease duration is gone. So if once this client right here gets an address, the default is 24 hours. So it will hold on to this address for 24 hours. However, it will ask this DHCP router to renew its lease after 12 of those hours have passed, 50%. And you can change that time by using the lease command right here. And then you can change the time on that, but we're not going to do that. Okay, so now that we have our DHCP set up, now we need to enable the service. And we do that from global config mode and using this command. Now, we should be ready to go. Let's see what we got. So right now, this is going to be our first DHCP client. See, it's looking for a static address, but now let's see what happens here. There we go. It now has the address of 192.168.0.2 and it also got the default gateway that we set, which is this right here, 192.168.0.1. And then it also has the DNS server that we put in, Google's DNS server, which is 8888. Okay, now that we know that that works, let's talk about something else. This network has two routers. So over here we have our 192.168.10/24 network, our 192.168.10.0/32 network, and our 192.168.20/24 network. Since broadcasts cannot be routed to different networks, if your DHCP server needs to give out leases to different subnets or networks, a DHCP relay agent needs to be set up on the interface pointing to the subnet network or network that needs the addresses. So, for example, this is going to be our DHCP relay agent. So these PCs, these clients, will be sending out broadcasts, but since broadcasts don't go past routers, we need to set up a DHCP relay agent right here on this interface, because these PCs are going to be the ones requesting address information. So, a couple things that you need to be aware of are you need to set up static routes for these here, because I don't have a routing protocol enabled. This network does not know about this network. So we just tell it, hey, this 192.168.20.0/24 network over here can be accessed via this network right here, specifically this interface right here, which is a 10.2, because this is the network that's right here. So now that we set up a static route going this way, we need to set up a static route going the other way as well, which I already did. So let me just show you that. Right here. So now both of these networks will be able to talk to each other through these static routes. But we still can't get DHCP discover requests across this without a couple more commands. So let's just go back here. And those commands are pretty simple. So, first things first, you set up DHCP on a router through global config, but in order to make it a relay agent, you need to put a command on the interface that is pointing to where the addresses need to go. And what I mean by pointing to is in the same network as the clients that need addresses. So we have this ready to go. So we go to the interface. And now that we are in interface configuration, we just need to tell it, hey, here is where the DHCP server is. And as you can see, 192.168.20.20, since my DHCP server is set up over here, .2020 is the address for my DHCP server. Here's my default gateway, and of course we're using Google's DNS. So we will go back here. Oops. We will go back here, hit enter, and now that this interface is a helper or relay agent, as soon as these discover messages go out towards this, this is going to say, hey, I know where that DHCP server is, and I know how to get to this network through that static route. So let's test it out. There we go. 192.168.1.2, 255.255.255.0. There's our DNS server. There's our default gateway. And we set that up over here. Services, DHCP, right here. So you can see you have to set a pool name, the default gateway that all the clients on this network are going to use, DNS server, start IP, subnet mask. All the information that we put in over here can be put in packet tracer on this DHCP server. But now there's something else. If you think you have everything correctly configured, but I just turned that service off, and there's still an IP address that comes up requesting. If it's 169.254.whatever, that means your DHCP failed and a PIPA is being used. Whenever you see this 169.254.whatever, your DHCP is not being contacted. So now that we have this address right here, let's go turn that service back on. And you can also from the command prompt of the client machine, this command right here tells it to release whatever IP address it had, because it's DHCP enabled right now. And then we can do renew, so it will look for that DHCP server again. And as you can see, all the information that's supposed to be propagated across that network is being propagated. So now that we know a little bit more how DHCP works, what are some of the security risks of using DHCP? There is something that is called a rogue DHCP server, which is a DHCP server that is not administered by an authorized person or administrator. This allows for man-in-the-middle attacks, which is a type of attack where someone is listening to your traffic while also sending it out to either the correct location or a malicious location. So, as an example, we'll go to End Devices, and we will say, put a PC here, right? This PC is a malicious DHCP server, right? So, because clients can only reply to one DHCP server and request only one address, if this PC, this rogue DHCP server, was connected, we'll say, was connected over here, in this case, the DHCP, this rogue DHCP server would be faster to give out addresses than this server right here. That means any traffic, any DHCP traffic would go to this. And there's ways to set it up to make this also the default gateway, while also sending it out where it's supposed to go. So, for example, DHCP request goes to here, pushes out an address, but it also sends this rogue DHCP server. This rogue DHCP server tells this PC that this rogue DHCP server is also its default gateway. So now any traffic comes to here, and then this rogue DHCP server, because it is this PC's default gateway, can push out traffic to go to, say, the internet or wherever it's supposed to go, but using a packet sniffer, they can get all of that traffic. Another thing that a rogue DHCP server can do is it can put out addresses that aren't actually supposed to be on the network. So I say this is the 1.0 network, right? So this rogue DHCP server is set up to tell everything that its new default gateway is 192.168.100.1 instead of 1.1, which is the default gateway right here. Now, all of these PCs that get addresses from this rogue DHCP can't get out of this network. They can't even talk to anything. That's called a denial of service. Another thing to think about is unauthorized clients gaining access to secure resources because DHCP has no method for authentication. So, what we know right now, if this isn't a rogue DHCP server anymore, it's just somebody who has access to a switch. Okay? We have sensitive information on this network. They walk up to your switch, plug it in, set their PC to request a DHCP address over here, and now this malicious person seems like they're a part of your network when they're not supposed to be. Another thing that can happen is once they can request one address, there's ways that you can keep sending discover messages with new credentials. This is called DHCP starvation, where a client provides new credentials each time it requests information from a DHCP server, thereby exhausting the address pool so no other client can get addressing information. So if they can't get addressing information, then they can't do anything on the network because they have no address. Traffic doesn't know where to go or how to get back. So that's what I have about DHCP. Here are these commands again. Let's go through them one more time. Step by step. Pick your excluded addresses. It can either be a single address like this or a range by putting a space like that. Low address first, high address second. Then we need to make a pool name. That's fairly intuitive. Don't just name it pool 1, pool 2, pool 3, unless there's documentation somewhere saying that, hey, pool 1 does this network, pool 2 does this one. And next, once we get into that DHCP/config, we tell it which addresses it can give out. Right here. Network. Service this network. This subnet mask. And then we can propagate a default gateway with this command, a DNS server with this command, a domain name with the domain name command with something like there we go. And now over back to this red network. Here are the clients that need addresses. This is the G01 interface right here. So we go to interface G01, IP helper address, which is the address of our DHCP server over here, 192.168.20.20, 192.168.20.20. So broadcasts can go across these networks to get to here. But you do need a static route pointing this way on this guy, and a static route pointing this way on this guy, unless you're using routing protocol. So I hope that helps, and thank you for listening.